We are going to talk about Taylor series. Essentially, we're going to take our Taylor polynomials and we're going to write them as series. Okay, so you remember our Taylor polynomials? Yes, Maclaurin polynomials. Now we're just going to write them as series instead of like a 4th degree polynomial like we stopped, right? Now we're going to keep on going. Write them as a series. Okay, what is the easiest group of functions to work with? Polynomials, okay? So all of this work that we've been doing has been taking transcendental functions, non-polynomial functions that stink, like sine, cosine, natural log.
Like transcendentalism.
Okay, this is too much. We write them as polynomials and they're easier to work with. So like, you know how your calculator approximates when it integrates?
Yeah.
Guess how it's programmed? No, I'm done. I have to go. I gotta go.
I didn't think she was there yet, but we drove her to the edge. I've never seen that. But wait, why did it play?
You just write some E.
I just want to sleep my eyes with my jalapeno chips. I'm listening to it and the Kirk's open jalapeno chips in her car. It's so hard and they literally were our eyes with water. It was so funny. It was not funny.
Do you notice how
For constant.
I have this written as a series?
Constant.
I also have this written as like the first few terms plus ... a general term plus ... because it keeps going towards infinity. Okay, this is what we call the general term. So sometimes I'm going to say, write the first 4 non-zero terms and the general term. This would be what I'm talking about right here.
I don't want to go to my car. We can have another Uber. My eyes were burning. It was not. You were so dramatic. I was so dramatic. Everyone was
I finally can show you that meme. The meme that you didn't understand.
What do you mean we didn't understand?
Until now. We didn't understand it if I did. What? N's, K's, it's fine. N's are fine.
I like the first two better.
Do you have a question?
She speaks more.
Can I airdrop it to you after class? If you know Taylor, you know McLaurin.
So just Taylor? Just Taylor. That's what I did.
The better Taylor.
Can you play Taylor Swift now?
No.
It's a Taylor Wordle. And it's all for Taylor.
Bozo?
I actually practiced the 2% of this.
All right, are we ready?
No. That will change.
Okay.
I made 3 more Taylor Swift. That's for this school year.
Okay, so we're gonna write the Taylor series for e to the negative 2x centered at 0.
This is like the butterfly effect. Butterfly effect. What's that thing where like people think one thing's happening? The Mandela. That's I love that.
Example. Well, this is true. Okay, so if our function is e to the negative 2x, what is f of 0? Seriously? 1. Our derivative would be negative 2 e to the negative 2x, making our derivative at 0 negative 2. Strive to survive.
Yeah, I did put my tires in red. I saw that. My mom was like, Grace got a flat tire in the neighborhood. And I was like, because I ran by.
Okay, are you seeing a pattern? Okay. Okay. We have 1 minus 2x plus 4 over 2 factorial x squared minus 8 over 3 factorial x cubed. And that's going to keep going. Well, this is a squiggle for like approximately. Do you see a pattern?
Yes.
Okay, so I'm gonna go ahead and put x to the n. What else goes in there? Negative 1 to the n. What else? 2 to the n over. How did we get that?
Because it's a pattern.
You notice how we have 1, negative 2, 4 over 2 factorial, negative 8 over 3 factorial. So we figured out the pattern. We noticed how, first of all, it's every other positive, negative, positive, negative. So it's negative 1 to the n. And we have 1, 2, 4, 8. We know the next one would be 16. Those are all powers of 2. Okay. over 1, 2 factorial, 3 factorial. We know the next one would be 4 factorial. The next one would be 5 factorial, yada, yada, yada. Okay, so we have the sum from n equals 1 to infinity of -1 to the n, 2 to the n over n factorial times x to the n. Oh, that starts at 0. Sorry. Sorry.
You should do some math ASMR.
Somewhat. I need to do what?
Math ASMR.
I am now with you. Okay.
Do you know what ASMR is?
Yeah.
Do you watch like makeup ASMR?
Okay. You will memorize these and they will make your life easier. So instead of having to do that process every single time, we can just remember that e to the x has a derivative of e to the x. So when we create the Taylor polynomial, we know it's going to follow this pattern where every term is x to the n over n factorial. Wasn't going to be cold enough. I had hope. I had a mustard seed of hope, but I knew in my heart it wasn't going to happen. Last year when it was -40.
No, we had one this year, didn't we?
No,
We had a snow.
we had a snowvid day. Okay, the cosine of x. The cosine of x. The cosine of 0 is, okay, and then we take its derivative and we get 0. And then the next derivative, we get -1. And then the next derivative, the third derivative, we get 0. And then the fourth derivative, we get +1. And the fifth derivative, we get 0. Do you remember this happening?
Yes.
So help me with the pattern. -1 to the n, x to the,
N plus 1.
nope,
N times 2n.
2n, yes. And the factorial underneath is also 2n. What do you think the third function I need you to remember is?
Sine.
Sine of x. What's the sine of 0? And then its derivative is 1. And then its second derivative is 0. And its third derivative is -1. And I'm going to stop saying the same thing over and over. You know what happens. We've seen it. Right, so what's our general term look like? We have -1 to the n, x to the 2n plus 1.
Can we just do the same and just start it at different numbers?
Well, we're going to try hard to start at 0, okay? Okay, so why am I making you remember these? First of all, they follow nice patterns, okay? Even if you don't remember them, you can figure them out pretty quickly, okay? But we can actually use these. So instead of, if I come back to here, instead of having to do this every time, if we have something that deals with e to the x, like this one, cosine of x or sine of x, we can actually use those shortcuts and work with them, sort of like what we were doing the other day with our power series, okay? Like if we had x squared times 1 over 1 minus x, we wouldn't have to go through all the process again. We could just write the geometric series and multiply x squared in it, okay? So we're gonna be able to do the same sorts of things, but more, okay? We can substitute into a series for x. So that example that we started with, instead of e to the x, it was e to the negative 2x. So what we can do is we can take negative 2x and replace x with negative 2x and make it look pretty, and we're done, okay? We can multiply or divide the series by a constant or a variable. We can add or subtract two series. We could differentiate or integrate. And then there's always the, hey, we have geometric series if we need it. Okay.
Upside down is my promise is the first one. It's so weird.
Yeah.
There's a boy that you had in class that has the best handwriting. A really good handwriting.
So Jackson Hazelhorse had really nice handwriting. And what's very strange is his brother Isaac has like the exact same handwriting.
Mm-hmm.
They have really nice handwriting. Trenton Brim, though, had the nicest handwriting of any boy I've ever had.
What about girl?
Girl, I don't know. Nope.
I don't have good handwriting.
I have to think about that one.
Lots of girls have good handwriting. Who has the best handwriting in this class?
No, you can't recall these things.
Yeah. It just looks like the girls.
Well,
It's not.
I was-
It's not Josh.
probably Rachel and Edie.
My handwriting can be good, but I like writing.
Worst handwriting, probably yours.
Really?
Yes. You go too fast. Did you know that one time you wrote your name like this? Or no, it was this. It was. And that was like what you wrote your name as. You just like forgot all the letters in between. Still not gonna call you that.
Maybe at the beginning of last year.
You had it in your-
Do you have Kylie Wilson?
I did last year. Oh,
She's really good.
she has probably the best girl handwriting. You're right.
With who?
Kylie Wilson.
Have you ever had a little?
No.
Oh yeah, Olivia, hers tiny.
Yeah, she writes like.
Yeah.
Have you ever seen Allie Hanson's handwriting? That's like I need like a plan.
Justin's handwriting is really small. Yeah.
Right.
All right, are we ready? You should really start wearing your glasses to school. Okay. No. So instead of doing derivative after derivative after derivative after derivative, we can take the fact that the sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, blah, 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 blah. And for the sine of x squared, guess what we're going to do? No, we're not going to square it. We are going to plug x squared in for every x that we see. What? Since we're plugging in 0, like, I mean, yes, we would do the chain rule if we were doing like a Taylor polynomial, but it's going to come out to be this. So do you want to do the chain rule over and over, or do you want to do a shortcut? So we would rewrite this as x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. And we would rewrite our general term as -1 to the n, x to the 4n plus 2 all over 2n plus 1 factorial. We're just using basic algebra skills there. Aren't you glad you didn't have to take 7 derivatives to get there? Huh? You gotta understand Taylor polynomials to appreciate or to understand where these numbers are coming from, right? Whoops.
Yeah, I need to voice my so fixated on this.
No, yours is great.
Oh no, I was the worst. I didn't make it. I didn't work. This is why I have really good handwriting the other day in economics. I feel like you should.
Dan, are you good?
It's just very.
All right. How about this? X cosine of x.
My handwriting on a good day. No, I'm just yeah, no. Like, wow,
Let's just focus on this example. Okay, so we know that the cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, blah, 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 where all of our terms are -1 to the n, x to the 2n over 2n factorial. So if we want x cosine of x, we simply get to just multiply x to our series. Hey, being a sorority girl is just fine. Okay, so x cosine of x, I can just take our Taylor series, multiply x to every term, including the general term. Okay, now the way that I'm writing this, I am writing this as the first four non-zero terms and the general term. If I wanted just like the series notation, then we could write the series from 0 to infinity of that general term. Okay, but it's going to be easier for us to work with the first four non-zero terms in the general term as we do all these operations with our functions. Okay. What? Because technically, like, especially in this one, there's a zero term in between each of these. You know what I mean? Okay, last one. Last one, people. Josh just asked, do we write these as two separate series? What do you think?
Yes. Actually, we should.
Actually, we should. Okay. So first of all, I'm gonna go ahead and write the 1/2 just off to the side. Is that okay? Okay. So e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, blah, 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 right? Okay, then e to the negative x is going to be 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial. How am I getting those? If I plug in negative x for every term, this goes to negative x squared stays positive. Negative x cubed, that turns to negative. So what's happening is we're getting that alternating piece because we plugged in negative x. Okay, now, what is 1 plus 1? What about x plus negative x? That goes away. X squared over 2 factorial plus x squared over 2 factorial. There's 2 x squared over 2 factorials. What's going to happen with our x cubed terms? They're going to cancel, but we're going to have 2 x to the 4th over 4 factorials, won't we? And we'll end up with 2 x to the 6th over 6 factorial. Do you agree? To where we are getting 2 times x to the 2n over 2n factorial. Do you agree with that? But we have that 1/2 out in front. So yes, we divide by 2 and we get 1 plus x squared over 2 factorial plus x to the 4th. Wow, this looks strangely. Similar to cosine, except we don't have the alternating piece. Bam, there we are. Yes, that was the last example. Would it matter though? Aren't you guys just gonna talk above me anyway?
I just wondered if I can